Grace College of Engineering, Operating System Laboratory. Lab code is 8461. Exercise number 2. System calls of Unix operating system. System calls. Program, first option is program using system call fork. So fork is the one of the system call. In C programming, if we see like this, fork open bracket close bracket means we will tell it as a function or method. Okay, but here in Unix operating system, this is the one of the system call, that is function. Fork is the function or system call. So fork system call is used to create the new child process. Okay, so in operating system we will tell it as a system call. So first one is system call fork, used to create the child process. Executing the process, wait process, exit process. So I already typed this exercise. Second exercise, first one. So these are all the header files we have to include. stdio.h, standard input output, standard library.h header file, universal standard header files. Here universal standard variables constants are available in this header file. Has include system or wait header files. So this header files is supported for the wait function. See here wait function is available. Wait function. This wait function will be work properly by using this header file system/wait.header files. So each and every header files will be supported for the particular functions. Standard input output function is supported for the printf statement. Okay, here main function. Main function with two arguments. First argument is argument C, another argument is array variable with a pointer. Asterisk is used to represent the pointer variable. This is the pointer variable. Pointer variable means it holds the address of the another variable. Okay, so the square bracket represent it is a array. This is the array. This we have taken this argument array in the data type of character data type. Here the variable argument C is in the data type of int. Okay, process ID fork. Here we are calling the fork function, that is fork system call. So it will call the system call. It will find out the process ID and assign to the variable PID. If the PID is less than 0 means the fork is failed, that is the new child process creation is failed. Okay, otherwise if the process ID equal to 0 means executing the process is null. Otherwise print the process ID. The process get parent process ID, get process ID. Using the get process ID method we are getting the process ID. We will run this program. Okay, for running this program we have to go to the terminal. Here we have to type GCC for compilation. If any error is there means it will shows the error. GNU compiler collection exercise 21.c space -o output O. This is the O. Okay, don't mistake it as a 0. This is the O. Next exercise 21. For running this I am giving the command dot slash exercise 21. The process ID, it getting the process ID. The particular process ID is 12535. So next exercise is second exercise. Program using system calls. The system calls are getPID and getppid, get process ID and get parent process ID. Okay. The program is looking like this. So these are the header files we included. Fork, by using the fork system call we will go to create the new child process. That particular process ID is -1 means fork failed. Otherwise if the particular process ID is equal to 0 means child process is under execution. So the child process ID is getting by the function name of getPID. By using the getppid, get parent process ID functions, we can get the parent process ID. Otherwise these both conditions are failed. The process ID is not equal to -1, not equal to 0 means this is the parent process. Okay, this is the parent process. So we can get the parent process ID by using the get process ID. Okay, you can execute this process by entering the command GCC exercise 22.c space -o exercise 22./exercise 22. This is the output. Okay, next second exercise. Second exercise, fourth option, program using system call execution. Here the system call is execution. Second, fourth exercise. So include UniSTD. So universal standard. So it is universal. The date is in the format of universal format only. So for that we are declaring the header files unistd.h main function. Using the printf statement, it will print out the statement executing system call displaying the date. So our system call is executing the process /bin/date. So the date is present inside the directory bin. The date will be displayed. We will execute this. GCC exercise 24.c -o exercise 24. /. For running I am giving the command as /. exercise 2.4. The date will be displayed. Okay. Next exercise is fifth option in the second exercise. Here the system call is wait and exit. So wait system call is used to wait for the particular process. Exit is used to exit from the particular process. It is terminating the process. Okay. We see the program. Wait. Here we are using the exit function to exit from the fork failed. Here the fork is not fork is failed because the process id is equal to -1. Fork is used to create the child process, but the process id is equal to -1 indicates the fork is failed, that is the child process is not created. From that we are exiting by using the system call exit. Okay. And wait, another one thing is wait. We are waiting to complete the child process end. Here the condition is process id equal to 0, so child process start. After child process start, it is running till the loop condition is satisfied. After the loop condition is false, it will go to the child process end. Till the child process ends, it is waiting. Okay. Waiting for the parent process end. Waiting for the child process end. After the child process is ended, it will go to the parent process end. So wait and exit. We will run this program on the terminal page. GCC. For compilation, I am giving the command exercise 2. Fifth option in the second exercise. .c -o exercise 2.5 /exercise 2.5. So the output is looking like this. So sixth option in the second exercise, program using system call status. Here we will go to use the status system call. Status of source and s. So file status of fd1 ampersand t. Creating, opening f status and status. So here file status. Here we are using the file status for system call. It shows the status of the file fd1 and ampersand t. This is the header file file control fcntl file control. So these header files is used to create the files, read the files, file copy functions. For all the functions, these header files will be supported. File error, the particular file does not exist. If the file is present, means it will copy the source to the some destination. File 1 from file 1 to file 2. File 2 it will be copy the contents. Okay, I'll run this program. GCC exercise 26.c -o exercise 26./exercise 26. Enter the file. Before that we have to create some file. Okay, I already created one file, so I will give that file name merci.txt. Source file size, it is copying, it's counting the size of the source file and destination file. Next, third option in the second exercise is program using system calls. So here we are going to use the system calls or functions, three functions: open directory, read directory and close directory. So again, directory is different from the file. In the directory it will contain some more files. Okay, so here we will go to declare all the header files. Header file standard stdio.h, parent.h. So integer data type, the method name is main, it contains the integer data type. Structure, here we are using the structure. Direct structure name is direct. Asterisk de, asterisk indicates it is a pointer variable. De is the pointer variable. So pointer variable contains the address of the another variable. Okay, so it's pointing the some here directory and ampersand asterisk dr. So asterisk is the pointer variable, asterisk dr is the pointer variable, pointing some another directory address. Okay, it contains the address of the directory. Here de arrow, means this is also used to indicate it is a pointer. So de variable pointing the directory name. De variable is pointing the directory name. Okay, so close directory. Before that we will go to read and open the directory, and we will go to read the directory. If the particular directory is not available in the particular system, means it will display the error message as could not open current directory. Okay, otherwise it will read by using this method, read directory method of with the parameter of dr. Okay, so dr, that particular directory name, it read the directory and it stored that directory contents on the variable of de. Okay, we will run this program. Okay, this is exercise 23.c ./a.out. It shows the directory content. Listing the directory content. Thank you, students. Say seventh option, program using system calls open, read and write. Here we will go to declare the files, declare the header files: universal standard.h, function control.h, system/status.h, system/types.h, standard input output.h. So here the main function type is integer. Integer means at last it will return something, it will return some value. See here which it is returning the value 0. Okay, so here we will go to discuss about some file operation. We will go to create one file and we are opening the file and we are closing the file. We are writing something into the file. These are all the functions we will go to do. So these are all the data types, integer data types. We are declaring the variable n and fd. In the character data type, we are declaring the variable buffer array with size of 15. Printf is used to display the contents at the display at the output screen. Okay, next we are reading. We are reading something, some value. We are reading some buffer values from the file, and we will go to store it on the variable n. Next we will go to creating a new file using open. So open is the method is used to create new file. So o create and pipeline function o read write operation. So 0777 indicate 7 means it indicates it's used to, it gives the file permissions with reading permission, writing permission, and execution permission. Okay, 0 means no permission. 7 indicates this number we are using to file permission, indicate the file permission. 7 the numbers is used to indicate the files getting the permissions for reading, writing, and executing permission. So next we will go to writing the input data to the file. Writing by using the function writing fd buffer n. So 3 variables we are giving as a argument to the writing function. Next only standard for fd for output device. So output device we are writing some values into the file. Next we will go to close the file by using the method close. Okay, we will run this program. As we got out, it is asking enter text to write in the file. So I am giving progress. So progress is typed in the particular file or writing in the particular file. Thank you, students.